Hi everyone, we are doing chapter 2 of Edexcel AS statistics, which is types of data. So, when we are doing statistics, we are finding the most repeated observation or the mean of any observation or the averages of observation. So, it is concerned with variables, and the variables can be non numerical, or I would say the variables could be a qualitative variable, or your variables could be associated with numbers, or we could say it could be a quantitative variable. So, your data is divided into two parts. One is your quantitative data, and one is your qualitative data. When I talk about quantitative data, it has something to do with numbers, numerical data. When I talk about qualitative data, it has non numerical data. Example, it could be the colors or your favorite animal. Okay. Now, when we talk about quantitative data, we have two types of quantitative data. That means it could be a discrete data. Discrete data, that means the data is going to take specific value in a given range. When I say the data is going to take specific value in a given range, it means that you specifically know number of girls in a family. If I say number of girls in a family, so the data is going to take a specific value in a given range. Number of bowling pins left standing, it could be one, two, three. So it would be the number, the data will be a specific value within a given range. But when I talk about continuous data, that means the data can take any value in the given range. A person's weight, distance between 2 points. These are examples of continuous data. They can take any value. Discrete would be specific value. So continuous data can take any value, and discrete would be a specific value. Let's take our example one. We have some questions over here, and we have to say whether each of the variables is continuous or discrete. Just for your reference, discrete is going to take specific value, and this can take any value. Sprint times for 100-meter race. Okay, so if you're talking about sprint time for 100-meter race, then there is length you have. So time can take any value. When I'm talking about sprint time for 100-meter race, this can take any value which can be determined by the measuring device. That means 9 seconds, 9.1 seconds, 10 seconds. So between 9 to 10 seconds, it can take any value. So this is a continuous data. Length. Length also can take any value. So this is a continuous data. Number of 10-cent coins in a bag. Now, when I'm talking about coins in a bag, that means this is going to take a specific value. Okay, this is going to take a specific value depending upon the number of 10-cent coins in a bag. So, this data is discrete data. Why? Because it is going to take a specific value. Either there will be one coin, or there will be two coin, or there will be three coins, but you will not have something like 3.1 or 3.2. Such number of coins will not be there. So there is not a value which would be within a specific range. It is a specific value. Number of boys in a family, you cannot have 2.3 boys or you cannot have 2.4 boys. So again, it is going to take a specific value. So this is discrete data. So discrete is going to take a specific value. It cannot be like I have 2.4 boys or I have 2.5 boys in a family. It's going to be a specific number. But if the data is going to take something within a range, it is going to be a continuous data. Okay, now let's talk about large amount of data. Now we look at discrete data. Discrete data is something that can take an exact value. So if you have a large amount of discrete data, if you see here, I have data for all of these people. If you add this up, that means if you're adding 3 plus 17 plus 29 plus 34 plus 12. That means you have data for 95 people. Okay. And this is the shoe size for 95 people. So the shoe size of these people vary from 39 to 43. So if you have a large data, a large amount of data, it can be written in the form of frequency table. So the frequency table, I will write the value which my data can take, the specific value which the data can take. So if we read at this frequency, frequency is telling me the number of students that can are taking this value. So over here, I say 3 students have shoe size 39. 17 students has shoe size 40. 29 students have shoe size 41, and so on. So a frequency table is nothing but it is a quick way of writing a long list of numbers. This frequency table can also be prepared for a grouped frequency. What is this? What is known as groups? We will come back. We will come ahead. These groups are known as classes in which you divide your data. When you are grouping your data, that means number of students are going to take value from A to B. Okay. So you need to know the classes. You need to know class boundaries. You need to know midpoint of the class. And you also need to know what is class width. We will come on this now soon. Now, if you look over here, the time is X seconds taken by random sample of females. That means females are going to take X seconds to run a 45 kilometers race or whatever it is measured into two different tables. So here I have two different tables where X is the time that is going to be taken by the females and N is the number of females. If I read this, that means two females take 55 to 65 seconds to complete a 400-meter race. 25 females take 65 to 70 seconds. So here I have grouped my data. Okay, grouping it, that means I have put how many people take 55 to 65 seconds. So 55 minus 65, 10. The class width would be 10. This is called the lower class boundary and this is called the upper class boundary. So in this table, I have grouped my classes from 55 to 65. Every class has a width of 10. 65 to 70. So no, they have a width of 55 to 65, 10. Then 65 to 70, 70 to 75, and 75 to 90. So the class widths are not common. Okay. But if you see over here, my classes overlap each other. That means 55 to 65, 65 to 70, It means my x can take any value which is more than or equal to 55, but it is not equal to 65. If a female runs a race in 65 seconds, it will come in the next class. So here the classes are overlapping. So this is called the continuous classes. Okay. Now over here, if you see the table 2, if you see the classes over here, 55 to 65, 66 to 70, 71 to 75, 76 to 90. If you see, your classes are not overlapping. Okay. So when the classes are not overlapping, you have to convert it into a continuous group. So when I'm talking about my table 1, okay, this is the class 55 to 65, 65 to 70, 70 to 75. What is this? This is a continuous data. There is no gaps. So if I am asked to define the class boundaries, so yeah, the number of classes. So the class boundary would be 55, 65, 17, and 75. These are the class boundaries. 55 would be the lower class, and this would be the upper bound. So this is the lower bound, and this would be the upper bound. Now, if I take over here, my table 2, the classes are not continuous. You can see the upper class is 65 and the lower class is 66 over here. So classes do not overlap. That means my females will take both the values between 55 to 65. Okay. So the class boundaries, if I'm supposed to write, I will minus 0.5 from the lower bound, lower class, and I will add 0.5 over here. So the classes have to be continuous. So it would be 54.5 minus 0.5 over here, and you add 0.5 over here to 65.5. 65.5 to 70.5, 70.5 to 75.5, minus 0.5 here and add 0.5 here. That means your x would be between 54.5 and 65.5. Anything above 65.5 would come in this class. The females would come in this class. So let's do a recap over here. The class boundaries for this table 1 would be 55, 65, 70, and 75.5. And the class boundaries for the table 2, where the data was not continuous, I removed 0.5 and added 0.5 and made it continuous. So it became 54.5, 65.5, 70.5, and 75.5. Now, another thing that they can ask you is, they can ask you to find the midpoint. So the midpoint for table 1 would be 55 plus 65. The answer divided by 2. So the midpoint for the table 1 would be 60. Midpoint for the table 2. We'll take the first one. You will minus 0.5, add 0.5. So it will be 54.5 plus 65.5 divided by 2. So the midpoint will still remain 60. Now class width for table 1. Upper bound minus lower bound. So 65 minus 55. My class width is 10. And for table 2, the class width again, upper minus lower, 65.5 minus 54.5. So the class width for table 2 is 11. Now we are doing exercise 2A of Edexcel Year 1 Statistics Types of Data. Okay. Now since you're doing these types of data, they want whether the variable is qualitative or quantitative. If it is numerical, It can be represented in a numerical value, it would be quantitative. And if it can be represented in a descriptive way, it would be qualitative. Height of a building, it is numerical, so it is quantitative. Color of the jumper, it is not descriptive. It is not numerical, it is descriptive, the color. So this is qualitative. Time spent waiting in a queue, it is numerical, so it is quantitative. Shoe size, numerical, so it is quantitative. Names of students in a school, it is a descriptive word. The name is a descriptive word, so it is qualitative. Now, exercise 2.8, types of data. Question number 2. State which of the following is true. Weight of apple is discrete data. An apple can take any weight between a range. So this is not a discrete data. There is not a specific value. So this is not true. Number of apples on the tree is discrete data. This is true because a number of apples would take a specific value. It won't come in points. Amount of time it takes a train to make a journey. The answer, amount of time it takes a train to make a journey, is continuous data. That means it will be between one point to the other, between a range. So this is true, it is continuous. Simhal collected data on car colors by standing at the end of a road and writing down the car colors. Car colors is a descriptive word, it cannot be number. Data she collected is quantitative. This is not true. The data she collected is qualitative, not quantitative. Now you have question number 3 of exercise number 2A. This is a group frequency table. And if I see frequency is always my n, and I have lifetime nearest 0.1 an hour. So this is distribution of lifetime of torch batteries. They want you to write the class boundaries of the second group. If you are supposed to write the boundaries of any group or any table, you have to first convert it into a continuous data. To convert it into a continuous data, you would minus 0.5 to the lower bound and you would add 0.5 to the upper bound. So class boundaries of the second group, my answer A would be minus 0.5, 5.5 and add 0.5 to the second group and 6.95. Write the midpoint of the fifth group. So this is the first, second, third, fourth, fifth. To do anything, first you need to make the data continuous. So this would be 9 minus 0.5. So it's 8.5. And to this I will add another 0.5 plus 9.9 plus 0.5. So this would be 10.4. And I'm going to divide it by 2. So the midpoint would be 8.5 plus 10.4 divided by 2. So the midpoint of the fifth group, that is the one I'm highlighting here, midpoint of the fifth group would be equal to 9.45. Let's go to question number 4. Write down the class boundaries for the third group. This is my first, second, and third. The first thing I will always check is whether the data is continuous or no. Since the upper bound of the first repeats the lower bound of the second, data is continuous. So if I'm supposed to write the class boundaries of the third group, I will directly write the lower bound and the upper bound. So it is 1.4 and 1.5. Midpoint of the second group. This is my second group. So the midpoint would be 1.3 plus 1.4 divided by 2. So the midpoint of the second group would be 1.35. With this, I complete exercise 2A of types of data.